In this video, we're going to look at error handling again. Now, we've talked a little bit about error handling, and the example I used was going through and creating a try-catch block, or try-except block in Python, in which case I divided by 0, which caused an error. The except block automatically was activated and it performed some kind of action. The action that was used was just, in this case here, is just printing out that there was an error. Now this is referred to as structured error handling because it has a predefined pattern or structure. And of course, the except block has additional features. You can have multiple statements. You don't have to have one statement. But one of the other things that's interesting is that you can capture the actual error information in an object. Now, it turns out that there is a class in Python called exception. And when an exception occurs, such as you try to divide by 0, an object is made automatically that is based on the exception class. So an exception object is automatically generated. You can think of it as soon as it runs there, a new object will be automatically created in memory. And then the syntax, except exception as E, will automatically hook it up, or should I say E up, to this object. That's a terrible arrow. That's even worse. So this is a neat feature because you can go through and access that object and its properties and methods. In fact, if you just print out E, it'll automatically go ahead and extract some of the data in that object for you, and you'll see the results. Let's take a look at that. Now, this time, we got division by 0. That was built in to the exception as a message. And there are other things in here as well. Let's see what else we can extract out of there. Let's see. It's called traceback, module. Let's use the class. Class tells you what kind of class was loaded and was used to create the object. So an object is a instance or copy of the class's code in memory. I often kind of draw it out like this. This was the class where the actual code was written, so this would be the exception class. And then when an error occurs, an object is automatically created from that class. It's as if you copy the data, the text over, or code over into a new memory address. Let's say that this one loads up at address, I don't know, 17. This one, on the other hand, would be a different address altogether. It's a object, it's a copy of that code, if you would. That's not exactly accurate, but it's good enough for now. Yep, I think that's going to be a 9. Yep. So when you ask the question, what class is it? And this is a built-in field, as we'll talk about in, I think, the next chapter or chapter after that. We'll talk about how you can make these on your own, but this is built into Python's exception class. Actually, this is built into Python's zero division error class, because this is the type of class this object E was made from. It was a zero division error class. So you can reference an error object or exception object, by just going through and creating a variable for it, and then you can determine what you're going to do about it, like asking what type of class it was, and if it was a class where you couldn't read a file, then tell it that the file needs to be created before you use the program. Or if it's a class, an object that's made from a class such as divide by zero, tell it don't use zero in the denominator. Now, let's talk a little bit about whenever you declare variables inside of a try block. In general, you can expect that in most programming languages, anything created in a try block will not be available outside of it. Decimal value is not defined. You may have seen behavior like this before. Let's say I go through and make an if statement. Okay, that will always run as true, and I will declare a variable in there. And I'll have a variable x equals test. So, can I print out x after the fact? It does. Now, I would tell you, most languages, that will not work. X will be only available within the if statement, in the if block. That is what you can expect. You know, a while loop is kind of like an if statement, except that it continues to process until somebody types in break. And it's also, the scope is actually variable declared inside the while loop is available outside of it. And this is also something that is it's unusual. Most of the time, if you declare a variable inside of a block, it will not be available outside of it. You can expect that. Python's just weird that way. And let's call the demo function and see if we can print x. Coordinate is unhappy, unresolved reference. And it didn't print out anything there. So since the variable was inside of a method, that was sufficient for it to be in the scope of only the method. And what we're seeing here is that in the try block, that's what's happening. Now, I would argue that with the while loop, with the if statement, it should actually not work. You should not be able to access things inside an if statement block or while block. Just because Python lets you do it doesn't necessarily mean it's a great idea. So assume in most languages that you will have what they call block scope, a programming block of code like a while loop, a for loop, a if statement, try except, select case. Those type of things will typically have block scope. And certainly we're seeing that in try except. Exception is a built-in Python class, and other classes inherit from it. So we talked about the pillars of object-oriented programming. 3 pillars of that are abstraction, polymorphism, and inheritance. We haven't done much with inheritance, but the way it works is like this. You can make an exception class, and it has some basic code in it. Let's say it has this line of code and this line of code, and that's all it's got. Then you can make another class that's based on the first one. When you do, it's as if it has the same 2 lines of code, but of course you can add in more if you want. Heck, you can even have a whole chain of these. Inherit some more code. I'd have the first two lines in there, and then of course I could add in more lines of code if I wanted, and so on. You can continue down. Now there are some interesting features about this. What's going to happen is that when I go ahead and divide by 0, the type of object that will be made in memory will be an object based on the type of error. So it may be like the third in a chain. The top of the chain is exception in this case. So this would be the parent. Hey, that's supposed to be a P. This would be a child. This would be, I guess, a grandchild. I'll just put child. Anyway, I have these parent-child relationships between them. Okay, grandchild. That's supposed to be a G, guys. So what will happen is that it will make a, let's say, a 0 division error. And I can check to see, Python will automatically check to see if the type of error that just happened is one of those. And if it is, it will go ahead and stop there and run the code. If it's not an object that was made in RAM that matches this type, that class, it will continue on to the next and try to test to see if it matches that. So remember that when an error occurs, it will automatically go through and make an object. This will automatically cause an object to be made in error because the error has occurred trying to divide by 0. When it gets down to this line here, it's going to check to see if E, which represents this object, is compatible with the 0 division error class. If this variable, E, is of the same data type, in other words, the same class, as 0 division error, it will go ahead and run that block of code. If it's not, it goes down to the next block, exception block, and see if that will work. And it would do that for a whole string of them. Let's look at an example here. I go through and I put an input. Sometimes I put in a number. Let's say sometimes I put in I don't know, character data. Who knows what I put in there? So I might get a value error. That would be a different class. So the object that gets made when I do this error message could be a value error or could be a 0 division error. What's going to happen is it's going to look to see if value error is the same type as the object that was just made. If it is, it'll run that code. If it's not, it'll go down look at the next block. It'll check to see if the 0 division error is a match. If it is, it will go ahead and run that code. And if not, it'll continue down. The exception class is a catch-all. It will catch anything, any type of error. Excuse me. It will work for any type of object, and that is an error object. And the reason why it does this is, I'll have to come back and talk about this later. The reason why I can do this is it is legal for you to make a variable of a parent and point to a child object. It is legal for you to make a variable of a parent, data type, and point to a child object. So if I have a variable, I don't know, I call it P1, and I want to point it, the variable type is a parent type. Or ENT. Man, that is horrible. I need a stylus. My writing is not much better. Okay, that's supposed to be parent. So that's the type. So when this object, if you have an object made up in memory, and that object is of a parent type, I'm really butchering this, excuse me. If I have a variable, and the variable is a parent type, it is legal to point to objects that were made from child type and grandchild types and great-grandchild types. I can legally point to one of these if it's made up of a child, or even if it's made up of a grandchild type. The reason for this, and again I will come back to this at a later point in time, the reason for this is the parent variable is guaranteed to have, for in our example, those 2 lines of code all the way down. It may not have the 3rd line of code or the 3rd and the 4th line of code. Excuse me, I had to stifle a sneeze. It may not have the 3rd or 4th line of code, that's true, but it's guaranteed to have the first 2 lines, and so it's legal for you to point a parent variable at a child object. On the other hand, it is not legal for you to point a child variable at a parent object, because a child variable would expect to have access to those other lines of code, and they just wouldn't. It's a very complex concept for a beginning class. I'm introducing it here so that when I come back to it again, you'll have at least heard about it. But for right now, just put it in the back of your mind. It's not all that important to our conversation here, I should say. Just remember that the way it works is put your specific error types before exception, because if you don't, exception will catch every type of error, and the specific ones won't run. Okay, it's time for me to copy some code and try it out. So I'm going to go ahead and run this code, enter in a number 4, and it does what it's supposed to. Okay, let's try again. Enter in a character, it does not do what it's supposed to. I have a value error, and it prints out, actually it didn't catch on the value error, that's interesting. I'm not sure why not. Oops, forgot to debug. Come on. Okay, enter a number. Let's do 4. Debug, enter a number. Let's do 0. So it checks to see whether or not accept as a match. It didn't find it as a match, so it moves on to 0 division error, and it checks to see whether or not this object is a match. In other words, or I should say the object that that variable is going to point to. It is a match And so it goes down to the next line. Let's try character again. Not sure why it didn't break on that. Oops. I thought for sure value error would break on it, but if not, what's interesting to me is that it should be going down and breaking on there was an unexpected error, and it's not doing that. That's kind of weird. Okay, well, according to this value, it's looking for a whole number, so maybe I should just read my notes. Yeah, that time it worked. That's value error seems like a very weird issue. Okay, so but it did catch on that. Okay, we'll step in. Jump down there, turkey. Huh. You know, it looks like it just never gets down that far, which is really weird. I have a feeling it may be something in PyScripter. Well, this video is already 21 minutes long, so not sure I want to keep going down, trying to figure out what's going on with that. But just remember that except should catch everything. Should apparently is the key word here, because I'm not seeing it catch everything. It should be printing out there was an unexpected error. Apparently this is something kind of weird here. I'm seeing the same issue in idle, so I'm not sure what's going on with that. I'll have to do a little bit more research, I guess. That's pretty weird behavior. It should always go down and ignore the default error handling and use your custom error handling instead of that. And the fact that it's not doing that is pretty much a clear violation of common practice. It should not ignore your custom error handling and just exit out of your code. That's kind of defeats the whole purpose of the try-catch block. Huh. Okay, well, how much fun is that? Anyway, I'm just going to have to ignore it right now because Python's going to work the way Python's going to work. I guess I've always assumed that it was working correctly. By correctly, I mean as an industry standard. This is a beginning programming class, so it's not really a Python class. So the takeaway from this is, I guess, always test whatever language you're working with. And here's the other takeaway. Python should not do that. Whatever language you're going to go into, expect it to always use your custom exception block and not the original exception. That is a very strange behavior. Okay, well, I think I'm done with this this particular video. Hopefully that made some sense. Nope, I guess I had one more thing to say here. Here would be an example of going through and working with your file. So I'll go through and open the file for read mode, but of course the file doesn't exist. And go through and read the current data. An example, I'd want to go ahead and use a try block to capture that and see if that worked. Now this should work just fine. That is such a strange aberration. Python reported the following error. Now that's just text I made up. And I'm extracting out the string of data from E. Cannot convert the file not found error object into a string implicitly, so I'm going to go ahead and extract out the information by using string. And now I go ahead and get no such file as found. Error number 2. It came from Python exception object. So this would be a way of using the try except block with your code that would open up the file. Very common thing is for the file not to be there. Oh, one other thing. Your try except block has the option to put a finally clause. What the finally clause does is it will go ahead and run no matter what. It'll run if the try block finishes successfully. It will run if the exception block finishes with an error. In other words, it will always run. It's an optional feature. You don't have to have it. If I were to go through and change this over to customer.txt, which I do have a copy of that right there, customers with an S. It would read the data, ask me to enter in more data, type in exit, and it still runs the code under finally, which is the program is stopped. So finally is a great place to do things such as cleanup code. Oops. If you want to have Python always do something, you might go ahead and I want it to always try to close the file. Let's see what happens. Okay, it stopped working. It closed the file. I should have been able to write data. That's great. Let's see what happens if I try to close it if it never actually was able to open. Change the name of the file and we'll run it. Okay, we got an error message. No such file, and I don't see any code here saying that the program stopped. It actually had another error. Object file was not defined. So if you try to do this, it means that you cannot try to close that because because of the block scope of try block. If this never opens, this is not available to close. It would be a natural idea to go ahead and put that down here in the finally block to always try and close, but as you can see, it won't work. You could of course go through and put an if statement. If obj file is not null, or none I should say, then go through and close. That would be one way of doing it. So you can work around that. And of course, if you had declared that variable outside and put it to none, so if I'd gone through and said obj file equals none, I could then go through and do the comparison, find out if it's true that it's still none, and then if it's not equal to none, then go ahead and close. That would be a workaround, but you'd have to make sure that you check to see if that was true. if you're going to put that code in the finally block. And now it's working like it's supposed to. Let's see, 5, and I'm too lazy to come up with a name, so I'm just going to do that. And the program is stopped. Do we get our new data? Oh, I forgot to set the, I forgot to put in the code that moves it to the top. Six. Oops. Program stop, and there's our data. So, with that addition, the finally block will always try to close it, whether it was successfully opened or not. And that's probably a good space for it. Doing cleanup code like that, this is considered closing your file connections or database connections, or doing any maintenance tasks, that's considered cleanup code and often goes in the finally block. Okay, I think that's everything I can tell you about this. You'll find some more information about try block, catch or try except block in the book, so I'll let you go and take a look at that. I'll see you in the next video. Guess that's it.